We have just finished a discussion of ionic compound nomenclature, and we're now going to look at the second category of compounds, molecular compounds, and look at the system of rules developed to name them. Now, of course, if we're looking at a molecular compound, we recognize that the substance is a molecular compound because it contains nonmetal atoms only, not ions, but neutral atoms. However, we understand that those atoms are bonded together through covalent bonding, and that bonding isn't necessarily an equal sharing of electrons. So you can have a more partially positive atom and a more partially negative atom in the compound. The convention when you're naming molecular compounds is to name or write the more partially positive atom first, followed by the more partially negative atom, and the name of the more partially negative atom will change to end in IDE, Ide. And of course, you figure out whether or not an atom is partially positive or partially negative using the concept of electronegativity that we discussed in a previous lesson. I do want to point out that you also need to use prefixes to indicate the numbers of each type of atom present. These prefixes are listed here below. We're going to cover them in a minute, but I want to emphasize here that prefixes are not needed for naming ionic compounds. You just look at the charges on the ions and figure out or determine how many ions of each type are present in order for all charges to add up to 0. So again, emphasizing you do not need to use the prefixes that I've listed here when you are naming ionic compounds. They are used only for molecular compound nomenclature. Now here's some good news. You see the word memorize here with these prefixes, but hopefully that memorization work has already been done by you because the prefixes here by and large follow the geometric prefix pattern. Example, if there's only one of one type of atom present, you use the prefix mono. 2 atoms of a specific type, di. Tri, 3, tetra, 4, penta, 5, hexa, 6, hepta, 7, octa, 8, nona, 9. That's not a very common prefix, so saying that again, nona, 9, and deca, 10. So hopefully these prefixes are ringing a bell to you and you already have this in your memory banks. Okay, so let's take this information and practice naming some molecular compounds that are written up here on the board. First thing to recognize is that all of these compounds contain nonmetal atoms only. So you're going to use this system developed for molecular compounds to name them involving prefixes. Beginning with a very familiar compound, CO2. We know the name of this compound even before we enroll in a chemistry class. The compound is carbon dioxide. So notice I'm picking up that geometric prefix di to indicate there are 2 oxygen atoms present in the formula of the molecular compound. And I can see that because oxygen is the more partially negative atom, it is more electronegative than carbon, its name is going to end in IDE, carbon dioxide. One other thing to point out, by convention, if there is only one of the first type of atom present, the more partially positive atom, then you don't need to put the prefix mono in front of it. It's understood. So when you say carbon dioxide, it's understood that there is only one carbon atom present without you having to indicate monocarbon dioxide. You just call it carbon dioxide. However, if there's only one of the second atom present, then the situation changes. Again, this is a familiar compound to many people. What is the name of it? Carbon. So only one carbon atom present, Prefix mono understood, but now we need to use the prefix mono with the oxygen and call this carbon monoxide. So notice what I've done here. I've taken the O off of mono. So I've removed that O off of mono because the element oxygen also begins with a vowel. And in the English language, two vowels adjacent to each other is not common. So in other words, this notation is funky in the English language, having mono end in O and oxide also begin with O. So we drop the O off of the mono and refer to this compound as carbon monoxide. So let me erase and just put the correct ending. Let's make it pop a little in red. Carbon monoxide, dropping the O off of mono. Let's move to our next example, SO3. Now be careful here. This is a very common error that I see with beginning chemistry students. They want to call this the sulfite ion because they know on their table of charges that there is this species SO3 minus 2. But notice this species with a charge of minus 2 is the sulfite ion, but I did not put a charge in the upper right-hand corner. This is not an ion. This is not the correct name for this compound. So an error, but a common one. So we're going to erase this, and we're going to look at this formula and name it like a molecular compound using the prefixes indicated above. So 1 sulfur atom, sulfur, 3 oxygen atoms, and now we have the tri for 3 oxide. So the name of this molecular compound is sulfur trioxide. The fourth compound, maybe you can take a moment, pause this, and name this yourself. 1 carbon, 4 chlorine atoms present in the compound. How would we name this molecular compound? Carbon tetra for 4 chloride. Again, chlorine, the more electronegative atom, the more partially negative, so its name ends in IDE, does not indicate that it's a charged ion, just indicating that it is the more partially negative atom in the compound. The last 2 examples, I want to give you some examples where you have more than one of the first atom listed. So how would we name N2O3? Now we need to use the prefix di to indicate that there are 2 nitrogen atoms present. Notice that we do not change the name of the more partially positive atom, right? So it's just dinitrogen. And then I don't know that I'm going to be able to squeeze it in here, right? I'm going to try with a trioxide. Right, so just fitting it in. The name for this molecular compound, dinitrogen trioxide. And then our very last example, P2O10, right? So 2 phosphorus, diphosphorus. Careful with that spelling of the element phosphorus. It is a commonly misspelled element, and spelling counts only here with nomenclature. So diphosphorus, I see that there are 10 oxygens, so I know I need the prefix 10, but that A in deca juxtaposed with the O in oxygen is not common in the English language. So we drop that A off of the deca when we are naming this compound. So here's that A, but we are going to eliminate it so that we don't have this combination of AO when we go to write the name oxide. So diphosphorus decoxide is how you would name this compound. Diphosphorus decoxide. And lastly, before we finish up our discussion of molecular compound nomenclature, I want to mention that there are 3 molecular compounds with common names that you need to know and be aware of throughout the rest of this semester. They don't fall in this pattern of molecular compound nomenclature, even though they are molecular compounds. And the first one is a very familiar compound to you. You recognize this. We would not call this dihydrogen monoxide. We'd call this water. So you need to know that water has a formula H2O. Of course, I know that you do know that, but the other 2 molecular compounds and their formulas may be less familiar to you. So you need to know whenever you see the name ammonia, which is a common name, that you're referring to the molecular compound NH3. No charge, neutral compound. A common mistake that students make is to look at the formula NH3 and call this the ammonium compound or the ammonium ion. But notice there is no charge here in the upper right-hand corner. This is a neutral compound. It is not the ammonium ion. The ammonium ion does exist. Its formula is NH4 with a +1 charge. So it's very easy when you're just getting your feet wet with nomenclature to make this confusion in the naming. NH3, no charge, is the ammonia molecule. The very last example that I want to point out is the formula CH4. This molecule is called methane. It's a major component of natural gas. It is an organic compound, and if you go on in to further studies in chemistry, you will learn much about methane and the family of organic compounds that it belongs in, the alkane family in organic chemistry.